Um, the main screen was what I wanted to look at though, and we've gone slightly forward. So let me go to that. Okay. Now, what I wanted to talk about was the idea of building sequences of lessons and the importance of reasoning, and then also kind of look at fractions. So reasoning is more predictive of children's long-term success in maths than their ability to calculate is. Now, they both predict long-term success, but reasoning is a more powerful predictor than arithmetic skill is. The other thing that I wanted to emphasize about reasoning, which hopefully will come through, was this idea of, rather than seeing reasoning as something that goes, firstly, we have fluency, and then we have reasoning, and then we have problem solving. I would look at reasoning as the thing, as the constant thread in the maths curriculum, that children are always reasoning. So they're reasoning as they learn to become fluent, and they reason as they problem solve. Now, whilst you would use some fluency skills whilst you're problem solving, I would see fluency and problem solving as being distinct, because problem solving is looking at solving non-standard problems, whereas fluency more refers to aspects of maths where there are more standard approaches. But reasoning, it will strengthen our understanding of both parts. So really, I would look at how do we build that. Now, having said about how reasoning is very predictive of long-term success, one of the reasons that fractions gain more prominence in the curriculum was actually because when it was changed, was because your understanding of fractions predicts your later math success very powerfully, because there's a big link between understanding fractions and then algebraic thinking as well, which was so helping children be successful in fractions will actually help them long after they've left primary school. So this will hopefully be really helpful. Now, the other thing that I wanted to emphasize about today was it's about fractions, but the principles behind what we're looking at will apply to any sequence of lessons. So what I really wanted to think about with fractions being the vehicle was about building learning sequences, and how different kinds of activities that you might use will differ. It's not like there's a good activity or a good question and a bad one, but it's more, where in a sequence of lessons would I place different kinds of questions and activities, and why would I do it then and not then? And so hopefully it will kind of strengthen the dialogue around learning, and basically share some research that I found really helpful when I came to planning lessons. There has perhaps been a debate, a kind of thing running previously about, well, is it better for children to have direct teaching, or maybe open-ended tasks are better and the teacher should be more like the guide on the side? And actually research now talks about the importance of both direct teaching, and that direct teaching is really important for children to experience. That more open-ended tasks are really important as well. But that it's about understanding where in a sequence of lessons children would need those experiences more, and where they would, and what that balance should look like. And that's what I hope to kind of articulate today. And it's basically, let's say at the beginning of whatever we're learning about, children are relatively and let's frame that around fractions. Children are, relatively speaking, they're novice in this topic, and they will develop expertise as we go through that sequence of learning. And the things that they require when they're novice are very different from the kind of learning experiences that they require when they get towards the end of that sequence. And I would say that the best way for me to articulate that difference is by thinking about working memory and long-term memory. And it's just this kind of basic idea that at first, in a sequence of lessons, we don't have that understanding to build on. So we need to build on our learning. It always builds on previous learning. And we've got a really limited working memory with which to process new information and ideas and things we haven't understood yet. And we've got a huge capacity for storing learning in our long-term memory. Now, early in a sequence of lessons, when children are relatively more novice at that thing, they'll benefit from more direct instruction, visual representations, to basically to unpick the deep structure of the maths so they can see that. Now, as we progress through a sequence of lessons, children must then not become reliant on the equipment that you use to build that understanding. But what they have to do is be able to do the maths without the equipment. The equipment is there to build the understanding, and then they have to, what we might call, build the abstract mental model. So understand it in an abstract form with numbers, not needing the equipment anymore. So we have to use the equipment to build understanding, then remove it. And again, that point might come with quite a load. So I wanted to have a look at how do we do that so that children have success there. Now, as children's knowledge and skill develops, we're getting towards the latter end of a sequence of lessons. Children will retain what they've learned more if they then have more of the open-ended tasks, the extended exploration, that they can make more their own, and they can have more kind of, if you like, more vivid memories of applying that skill. And if they've had the chance to do that, then it will be retained better in the long-term memory than if they haven't gone through that process. And so it might be like for example, more open-ended tasks. There's a lot of evidence that shows if it's too early or children don't have the required expertise to access that, it can have very little impact there. Children might need more of the direct teaching, but the greatest value might be more later on in a sequence of lessons. And again, some children might need a greater proportion of time with that direct instruction. And some children might be able to have a greater proportion of time on the more open-ended tasks. But that's the kind of picture that I'm going to try and paint. How does that look? A couple of other things that we'll look at is, one is variation. So making sure that children can connect the learning experiences really well. You know, if we're building on long-term memory, we've got to make sure that the maths tasks that children experience aren't too different from one another, that they can't connect them very well. And then we'll also come later on to look at retention. How do we make sure that we strengthen long-term memory in a way that lasts? And some kind of little pieces that hopefully will help to do that. So that's the plan. And the other thing is, there's lots of little points where we'll stop and invite you to put comments in the chat about answers and thoughts and so on. So that'd be really good if you felt comfortable to do that. Okay. Let me just check my notes. Okay. Now, the first thing that I wanted to have a look at was this. So let's say eventually we want children to be able to do things like this. So we might want them to answer 2/3 of a number equals 14. We might want them to look at fraction and decimal equivalences. So like this question here, which I'll give you a moment to read. And it might be they need to do calculations eventually, like 3/4 plus 5/8. And what I was wanting to ask you about to start off with were the following things. So what precursor knowledge will children need to have to do any of those tasks or questions? What will they need to understand first? So what will underlie that before we start teaching these specific things? How do we represent these ideas visually? How might we do that differently for each question? So specifically, these are three very different, whilst they're all fractions, they're very, very different concepts in fractions. So representations that you've used that have been helpful to uncover that. Any common mistakes or difficulties children would have? So again, what would be brilliant is if you can load those thoughts in the chat. That would be great. I always need to stop to have a drink, because otherwise my voice dies away. Okay, so bar models is great. And again, if we can add any question in particular when we're looking at the bar model, all of them, and again, that's great. So again, if you're writing, just so I can see, it is all panelists, and otherwise it is all panelists and attendees. Okay, yeah, excellent. So they've got to understand unit fractions first. So first of all, before we get 2/3 of 14, I've got to get to a third. What's a third and how do I know? Your understanding of a numerator and a denominator. Okay, so common multiples and factors. An instant times table recall. So again, if we're looking at the load and the working memory, that's much lessened if children have automatic recall of the times table facts. And of course, if they don't have that, then they could still access the tasks, but that will take a lot more load on their children's working memory. For some children, it might be you're thinking, well, I might lessen the range of the times tables that they're having to use if that's going to overload the working memory. Great stuff. Let me give you a moment. Any other representations? We've had the bar model, and ways we can understand the size of fractions. Any other comments? Feel free to load them in. I'll give you a couple more minutes. A couple more moments. Okay, and let's keep going now. What I wanted to do was articulate in this session like the differences between these types of questions and the different experiences that children need to have to kind of understand fractions first, so that then almost like the success in the calculation becomes the byproduct. So rather than children having too long, actually us having to teach them procedurally, if they understand fractions, I'm thinking they understand fractions with great security, then the actual adding fractions and the mechanics that they then have to master are easy because we're almost on fertile ground. And I then wanted to look at this idea that if we get those foundational experiences, how we can then build sequences of lessons, thinking about how high quality, direct teaching, build understanding first, and then more open as children progress. Fraction wall as well, how to use it for equivalence, and we'll look at a kind of something very similar to a fraction wall as well, which hopefully you'll find helpful. Now, let's start by unpicking what I would say is the different foundations for fractions. And one of them that I would say that I actually got this idea from a guy called Mike Askew, if anyone's heard of Mike, another maths guru. And he was talking about how children often experience fractions just as the whole and the part and so on. But a lot of fractions is also around division. And children seeing the link between fractions and division, first of all. So what I'd often do is give children contexts where they see fractions as sharing. Now, one of the first times I remember doing this, and this is again from a suggestion from Mike, is saying, if you say to my year 1 class, if I said to them, what is 2 divided by 4, then they wouldn't know. And they might say, I can't do 2 divided by 4. They wouldn't even know what it is. But if I gave them 2 pieces of toast and there were 4 of them, they wouldn't say, oh, actually, I can't do that, Mr. Metcalf. They would do something. And this is good because it kind of ties into children's intuition. So examples like these I might give children, and we might explore one or two of them first. And then I could give children these examples and say which involve fractions. And they can often say 3 pizzas shared between 6 children. This involves fractions because I need to split up the pizzas. 10 toys shared between 4 children. Actually, that doesn't involve fractions because, of course, you can't cut them up. And then, like 4 children share 3 pieces of toast. So why do we need fractions there? Because we can't answer that. We can't sort that properly using whole numbers. There's more children than pieces of toast. And then grapes. It could be that if I gave children 21 grapes and there were 4 of them, they would probably end up with 5 each. And then there'd be 1 left. Now, would we use fractions there? Probably not. But you could say the answer is that we'd have 5 1/4. I was checking myself then. But in reality, and I like children kind of thinking along those lines and tying to what they kind of naturally know. And I often start there in fractions in building sequences of lessons. So this is one that I've used. 4 hungry friends, 3 pieces of toast. And then essentially children will often have a go at this. And like the way that I would do this, and the way that adults often think about that, and the way that sometimes children do, is they take 2 pieces of toast and cut them in half. And so we have a half each. And then we have that last piece of toast and we split it into quarters. And what we see is half add a quarter. And what children often do is they'll take that and they'll quarter all of them. So they'll share each piece of toast fairly. And so each person gets a quarter and a quarter and a quarter. They get 3 quarters. And what we kind of come to see is that a quarter and a half, they're actually the same. Again, you could do that with quantities like 7 pieces of toast shared between 4 children as well, you know, in that we can have 1 and then we'd have be sharing those other 3 between 4. Now, I just wanted to share some examples of how this is then extended. And so, sorry, that was just one of the drawings of this same task. So 4 hungry friends, 3 pieces of toast, and children seeing it in those different ways. Now, this is a question that I like, again, using the kind of context for children thinking in real terms. So 9, and this is from a resource, one of the IC reasoning questions as well. Everything on this presentation, of course, you have, so hopefully that'll be useful. 9 boiled eggs shared between 4 people, how many eggs each? And children thinking, first of all, recognizing they won't get 4/9 of an egg each, because you'd actually get more than 1, because there's more eggs than people. And it's then thinking, in this context, would I be quartering an egg or not? So again, kind of deepening children's thinking in that regard. Now, I wanted to have a look at how I've used this, and these are from one of the tasks from IC problem solving. Now, this is much easier when done practically than when done where it isn't. I can't physically do it. But 4 girls share 5 pizzas equally. 6 boys share 7 pizzas equally. All the pizzas are the same size, and we essentially have to figure who gets more pizza. And generally, what of course we end up doing is we share 1, so each person gets 1, and then the 4 girls are splitting their 1 pizza equally, and the 6 boys are splitting their 1 pizza equally. And whereas we might well think that a 1/6 is more than a quarter, when I've got 1 and I'm sharing it between 6, I instinctively know I'm going to get less than when there is 1 that's shared between 4. And it's kind of tying to what children know, that they can understand more complex maths if we've done that. Now, I wanted to give you this one. And this is the same idea, but this is what I'd call like taking the same maths with the opportunity for children then to work greater depth. So 4 children are about to share some pizza. And then Harry joins them. He brings another pizza to share. Now that Harry has come, will each child have more, less, or the same amount of pizza? Again, your thoughts, comments in the chat on that would be great. So more, less, the same. And how you know. Let me, again, I always need to stop for a little drink, because otherwise my voice goes. Okay, so we've got one coming through, so they could reason and show an example. And so again, and I'll not say whether we think it's more or less, or because that one just came to me. But yeah, let me give you a moment or so. Is it more? Is it less? How could they show it? How do we know? Okay, and I'll keep moving. So the idea here is that if each child has, if the 4 children had 4 pizzas, another child comes and he's got a pizza, then we all still have 1 pizza. If the children had more than 1 each, so let's say they had 5 pizzas between the 4 of them, and then one person comes with 1, now each they have less. Whereas if they had less than 1 each, so let's say they had 2 pizzas, and then one person comes with 1, now we each have more. And again, in a great way of deepening to then expand on that idea. But anyway, the thing that I like is to get the idea of tying to children's understanding of fairness, essentially, and using their understanding of, deepening their understanding of sharing in fractions. Now, what I wanted to come to then was how we also need to look at and go deep and use real examples of parts and wholes for getting children to understand the core ideas of fractions. And I would say if we have a long time on this before and then feeding the visual representations, then when we come to a lot of the calculation we need to do with fractions, it is so natural and easy to see. So what I'd often do is look for examples, and I'm going to share as much as I possibly can in this session. I want it to be as useful as possible. Let's say I give an example of England as a part. So England is a part of the United Kingdom. So there England is the part and the whole is the United Kingdom. And I could say, and a part of England is Cheshire. So this time, England is the whole and Cheshire is a part of the whole. And I could say, for example, like in this case, England is quite a large fraction of the United Kingdom, but Cheshire is quite a small fraction of England. And then we might look at another example, like a tree. Can we think of a tree as a part and a tree as a whole? So a tree is a part of a forest. What about the tree as a whole? Well, maybe the trunk is a part of the tree, or maybe a leaf is part of the tree, and so on. And then I'll often give children these examples and say, I want you to think for each one, can you describe it as the part and can you describe it as the whole? And for children to come up with their own examples. So they might say, the buttons are part of the cardigan. The cardigan is part of the school uniform. Or fingernail is part of a hand. Hand is part of the body. And thinking of other examples. Now, if I want to deepen there, I might think which is the larger and smaller fraction there, comparing those parts and wholes. And again, children come up with lots, and there's loads of different ways you can do that, or other examples. Then I've moved on. I think this again is one of the other IC problem-solving tasks that I often, having explored those ideas in more depth, we often get to. And I like this for exploring a lot of the big ideas of fractions. So children actually understanding, if we order these fractions from smallest to largest, we could look at the trunk as a fraction of an elephant and compare that to the wings of a fraction of a butterfly, and actually come to see that even though the wings are smaller than a trunk of an elephant, the wings are a larger fraction of a butterfly than the trunk is as a fraction of the elephant, because essentially in fractions what we have is this comparison of the part and the whole, and that's what children need to understand is in this form of fractions we're comparing the size of the part and the whole. Now this is an example then, these are from the lessons that I've been putting up recently. So this is an example from the year 5 and 6 lesson, like exploring the same thing, except this time we're looking at kind of almost slightly different forms of number. So we have here, we're comparing the neck as a fraction of a giraffe, the frame as a fraction of the bike, and a morning as a fraction of a day. Now I could give examples where I could calculate it exactly, or I could have examples here like these ones where generally we have to estimate. So how long is the morning, or the frame, and we're thinking, is the frame more than half of the bike? And again, and then able to compare those fractions before we're going to the images, which will help children when they do a lot of calculation. Now, again, a way that I might go with children up at Key Stage 2, and even as a way of deepening, is giving examples like this and asking children to order the fractions. Now, they can't name the fractions, so they couldn't say what fraction of either shape is shaded, but it would be possible to order the fractions if I realize that what I'm essentially doing is I'm looking at the whole and I'm comparing it to the part that I have, or I'm comparing the part to the whole. How many of the parts would fit in the whole, to help me to order those fractions? And kind of, again, we're looking at some of these key ideas. Now, then I would move to images, which will, again, help when children come to calculate. So, and again, I would look at lots of depth here. So this is an example I've actually used in Key Stage 1. So is the shape half blue? And having lots of examples and non-examples of a half. and excuse me a moment whilst I just check my notes where I'm going to. Oh yes, that's where I'm going to. And then like a little sequence where I vary the images children see, and really dig into the reasoning. So I've used this one a lot, where I'd say, what fraction's blue? And the children say, it's a half. And I say, why is it a half? And they say, there's two parts. Okay, what fraction's blue? And they say, either, I'm insistent it's a third because there's three parts. And they say, no, it's a half. I'm saying, no, it's a third because look, there's three pieces. You said it was the number of pieces. So, but they know it's a half. And now they're having to change the definition. And so we kind of could go back to this one and say, so what actually makes this a half is how many of that part would fit in the whole. So this is still a half because I could still get two of those sized parts in the whole. So the parts are the same and the whole's the same. And then I could look at this image, and we'd say this is a quarter. Why is it a quarter? Again, four equal pieces. So what fraction's blue here? Now, even having seen the previous image, I change it slightly, but we kind of know it's not a half. Is it a quarter or a third? And of course, the point I'm trying to make is it's the same part in the same whole, so it's still a quarter. And again, I could flip between the images to kind of emphasize that. I would always, again, look at thinking about likely misconceptions, and really important in developing sequences of lessons. Having explored this, then we then look at examples of correct and examples of incorrect and discerning between them. So, you know, we've got two quarters. I might think that this is two quarters if I'm comparing blue to white, like a ratio. And of course, what we have to understand is it's 2/6 because it's the number of parts. It's the denominator is the number of equal parts, and the numerator is the number that are shaded. And again, I might then give this example. Is it 2/5 or 2/6? To see if children, are they then thinking, well, how many of these sized parts are in the whole, or are we just counting the parts? Now, a nice way of taking this idea and trying to deepen it again might be looking at this and asking children to estimate the fraction, first of all. And why can't we work that out exactly? And what could it be? And about how many of those parts would fit in the whole? And then, of course, what I could do is move it around. So that's the same part in the same whole. And then, again, draw the line on, you know, so it's still the same part in the same whole, but perhaps that would help us. Then we can see it's a third. Now, if I was looking for equivalent fractions, what I could do is just put a line down the middle. I should have done that, actually, a line down the middle, say what's the same and what's different, and to actually get this idea that they're a great image for seeing that it's the same. Now, let me just give you a moment on this one. So in the chat, what would be great is if you could put, what I might ask children here is, do you need to estimate? Is this a question where you're estimating the fraction? Or is it a question where you can work out the exact fraction in each of those instances? So anyone, if you felt comfortable, again, in the chat, which coloured one can you work out the exact fraction that is shaded? And how do you know? Or any that you know that you can work it out exactly. Again, feel free to comment on that. Okay, so orange has got equal parts to refer against. Yep, so we're happy with that one. Okay, so looking at splitting, it's an interesting one. That so we're looking at splitting. You know, so the first two we can work out exactly. That's true, because another line here, you know, and we can see there that we essentially have that in equal. That can be broken into those equal parts. Yeah, and then this last one's very straightforward. Once they move the blue down, very good, and we get this idea that that the green part, I don't know how many green parts are in the whole, and whilst I couldn't name the fraction of either of those parts, if I actually combine them together, then I have a quarter. So I like that one for building children's reasoning. Now, what I wanted to go, this gives us great foundations for understanding then fractions and equivalent fractions. And when children are fluent here and they play around with these ideas, it's much easier when we then come to calculate. But what I wanted to do is show you, like, far and away my favorite resource when it comes to actually And this you'll find, I'll show you the links. You can print this from the website. And again, it's free. The fractions cards. Now, I like the fractions cards, and I think there's advantages to the fractions cards over a fraction wall, just because you can move them around and it's easier to see. So these are all the fractions cards, and the idea is that this is 1, and that half is some fraction, you know, that's half of 1. So you can get 2 halves into a 1, and that's the same. Now, the way that the fractions are up, now, of course, I could compare a 1/6 and an 1/8, and I could see that an 1/8 is smaller than a 1/6 because it's split into more parts. And again, I could demonstrate the size of 1, you know, by looking at that 4/4, and you still just about see that, is the same as 1. So they, you know, really, really handy. Now, the way that the fractions are written, if you put them the right way up, as in the way the fractions are written, if any fractions are equivalent, you can overlay them and show that equivalence. So let's say, for example, I can see a half is equivalent to 4/8 by placing them on top there. And I can see a quarter is equivalent to 2/8, and so on. And then the hidden hero of this little piece are our 12ths. And the reason that I say that is the 12ths, obviously we could put 6/12 on the way the fractions are written onto a half, and I could see that 6/12 is the same as a half. I can put 3/12 onto a quarter to see that 3/12 is the same as a quarter, but I can also put 4/12 onto a third, and to show that they're equivalent also if I'm putting the fractions the right way up. So those, I think, are really helpful. Now, there's a few things. So again, comparing fractions, brilliant. And we'll come to look at these for improper fractions as well, which they're kind of fantastic with. Now, there's one thing that I just wanted to mention before I kind of came to have a look at a calculation, which was this. So what I would avoid is showing fractions in terms of saying, you know, so what fraction, and saying this is 2/3, because whilst that is of course true, let me just get Bluetooth on these counters. If I then look at that in terms of adding fractions, it kind of adds some complication, because if I was doing 2/3 add a half, it would seem very much like this. So that kind of doesn't lay the foundation in the same way. And again, it's kind of shown that 2/3 and 4/6 is equivalent, whereas this 4/6, I've got that wrong, I think, haven't I? No, yeah, I have. I've got it right. 2/3 and 4/6 is equivalent. It's like 4/6 looks more than 2/3. So that isn't the representation for that reason that I would use. Okay. Now, the question that I put on the board before was 3/4 add 5/8. Now, again, the thing that I would want to emphasize is the fractions cards, I think, are brilliant for showing calculations and showing the reasoning behind calculations. And of course, we don't want the children to have to become reliant on them, but they are a bridge to them understanding in abstract. So if we were doing 5/8 add 3/4, what we would probably do is say to the children, well, what you can't add 3/4 and 5/8. So what have you got to do? You've got to make the quarters into 8s. Now, of course, with the fractions cards, you can actually model that. So we can make them into 8s there. And so then I've got the 3/4 into 8s. And then what I'll have to do, and I'll just put them on there, so I can see that that's the same as 6/8. And then I can actually add them, you know, so I can put the 8s on here, put 3/8 in here, 2/8 there. And so I'll see that I have 1 and 2/8. Now, the other thing that I think the fractions cards are great for is also, and what we'll come to, is children being able to see calculations in different ways as well. So in fact, what I'll do is I'll come back to that calculation in a moment. But again, fractions cards, just a fantastic representation. Let me go to new share and back here. Now, let's say we're asking children to add fractions, and we've represented and we've seen parts and wholes, and what we're doing is asking children to do lots of different things all at once. So we're asking them to think, well, what's the common denominator? Have you found the common denominator? And then they might have to think, well, what do I then add? And then I might have an improper fraction, and I have to present that as maybe as a mixed number. And there's all these different steps. Now, the fractions cards are brilliant for modeling that. But if we want children to, in this sequence of lessons, if I would start with the fractions cards, then I would think, well, at this point where we have to remove them, we don't want, what can be difficult for some children, if you say, these are all the steps you have to do, I'm going to show you how to do them all. Now you have to remember them all and go and do it. Now, my suggestion would be, see if you can, at this point in a learning sequence, when children are relatively novice, break that down into smaller steps. So, for example, for each calculation, choose a common denominator. So I'm not asking the children to actually answer the questions. I'm just focusing the thinking on one part. So again, they will hopefully not be overloaded. So for each calculation, choose a common denominator. Like this one, 3/5 add 3/5, because it's going to get the children to think, well, is it the numerator that has to be the same or the denominator that has to be the same? 2/3 add a 1/6 in looking at, you know, which fraction do we have to change there? And then children just have to say what the common denominator is. They don't actually have to do the calculation if the calculation is the challenging part. And then again, like examples like this one, because some children might think the common denominator is 10. Otherwise, we might see actually it's just a half add a half. So lots of chance for thinking going on there. Now, similarly, it might be I just have circle the calculations where the sum is a mixed number. Explain how you know. And there, again, giving the children a chance to kind of reason around that. How do we know it will be a mixed number? It will be more than one. And then just focusing on that aspect of the question rather than them actually having to do all the steps and answer the question, because we may not be ready for that yet. So we don't want to kind of overload children at that point. Now, let's say and then again, at this kind of early stage, what we might do is be using the equipment a little bit and starting to phase that out. And then really important thing to focus children on is the difference between, like, one form of variation essentially is the difference between correct and incorrect, and getting children to explain mistakes. So like mistake A, we just, you know, the person has just added everything and we get 4/12. And again, if the children have done that, we might need to go back, have a look at the fractions cards to show why that you know, that it doesn't work. And then, for example, a quarter add 3/8. Maybe we've thought we've got to make it in eighths, so we haven't added the denominators. But again, we haven't changed this to make it 2/8 when I've added it to 3/8. But getting children to think about, like, what mistakes will they make, and how can I get them talking about those mistakes from the perspective of the expert. Now, another thing that I'm a big fan of, and we'll have a look at lots of examples as we go through, is the idea of small variation questions. So the idea here is, again, it's if rather than giving children like just different fractions to add, if I put questions in a sequence, they might look at them and think, well, what's the same and what's different from here to there? So again, this can be a way of bridging in where children are early in working in abstract. If we want them to access and actually see this change has this effect. So the design of this sequence is 1/3 add a 1/6. The idea that I need to make that into, you know, that I could make this into 1/6. And then 1/3 add 3/6. Well, it's the same, except I've just got more 1/6. And then 2/3 add 3/6. The idea that, well, then this 2/3, I'm not just adding another 1 here, because of course 2/3 is 4/6. And also we have this step of we're going beyond 1. But that's kind of phased, if you like. The challenge is phased. And again, the examples like a quarter add a 12th, change the quarter into 12ths. And then I get 3/4 add a 12th. So slightly different here, because now again, we've got to make sure that we've got the 3/4 in 12ths as well. And then again, we have this example where we then border over a 1. but having questions like that little variation that comes in for children to see those connections between questions. Now, as we're developing expertise, I would then try and open up slightly, and getting children, first of all, talking and seeing different strategies, obviously teaching different strategies first, and then children seeing different ways. So this I wouldn't do early in a sequence of lessons, because children wouldn't have the skill to talk about this in the ways that I'd want them to. The other thing I really like about rank by difficulty as a technique here, and again, I talk about fractions as being the vehicle for exploring, because this is the same in so many curriculum areas. But now I want to open up, and rank by difficulty I really like, because you don't actually need to be able to answer the question to engage in the discussion. And children are likely to give you the answers anyway. But when I say rank by difficulty, it will focus their attention on strategy more. Can I give you a moment in terms of questions you would either think are easier there or harder, or what strategy it draws your attention to? Any thoughts on why these examples have been chosen? Again, if you could put the comments in the chat, that would be brilliant. You're generally writing them to all panelists, which is just me. So all panelists and attendees, if you want everyone to see. I tend to read them out anyway. I hope that doesn't put you off. So again, any comments about any that you think are relatively hard or relatively easier? Okay, right, here we go. So those are the same denominator will be done first, or easier perhaps. Then we and then it'll likely draw children's attention to, well, which did you think was harder and easier out of 3 ninths and 7 ninths and 4 sevenths and 2 sevenths? And they're likely to compare those. Easier when the denominator is the same. We can just add the numerator, and then again, it's probably easier still if we end up with a proper fraction. And then we've got, for example, okay, so we've got examples then, if we're comparing the other 3, we're perhaps talking about something along the lines of how relatively easy or difficult is it to find a common denominator in these examples. Now, I like throwing in 3, 6, add 5 tenths, because it could seem, to some, it will seem as, and to many adults as well, as the most difficult, because it's very hard finding a common denominator. Let me just have a look at that that's coming in. And equally, we could just, often children will just look at that and say it's a half out of half. So that's the easiest one. And then we might naturally compare a fifth and 3 tenths. And this is about, well, you can make the fifth into tenths, and that's easier than adding thirds and fifths, because then it's harder to find a common denominator, is kind of where we're going. But that and rank by difficulty is great for children designing their own rank by difficulty questions as well. That is something that I'll often get them to do. But in designing a rank by difficulty question, I'll want them to think about which different, have them where there's different techniques that work for different questions as well. Let me come back to that question that we had, 3/4 add 5/8. One thing that I would also often look for is questions that children can answer in different ways. But what they'll often do is, if they found a way of answering it, they've got the answers. They don't want to give you any more. So I would often try and frame this like this, and look at and try and model. And 3/4 add 5/8 is my favorite calculation for doing this. Now, again, just let me step back a minute just to say that this is about building a sequence of lessons, and this principle of start with the visuals, remove the visuals, build in small steps, then broaden. So if you're not adding fractions, it doesn't matter. This is just the vehicle for explaining that idea, that principle. So let's say 3/4 add 5/8. And I've got these options for children to see, these different calculation methods. And again, if I just show you on the visualizer, so there we go. So we had, let me tidy it up a bit, Gareth. So we had our 3/4 add 5/8. Really like this one, because we had that standard method of make the quarters into 8s and then move the 8s across, which we could do. Equally, we could see for this one, I could just think, I'd just add a 1/2 and a 1/2, and then add the 1/4 and the 1/8. So that would make the 1/2 and the 1/2 would make a 1, and then I would have the 1/4 and the 1/8, which is, which we could see as being 3/8. And the other thing that children can do is actually just look at the 3/4, and then, sorry, I've made this a mess now, and think, well, how many 8s would I need to add? So rather than necessarily always having to go and convert the fraction with a smaller denominator, they could look at that. And if they literally have this, they'll often say to do this, well, the easiest thing to do if they can see it is make a whole, move 2 of the 8s across. But brilliant for seeing different options. Now, again, like I wouldn't want to, let me go back to here. I wouldn't want to launch in with this early on, but then we're broadening as the sequence is going on. Now, I don't like to give is try and lecture people about what greater depth looks like, or we need to deepen and give children open tasks and so on and so on, because I always think you just need to have the tasks. Now, hopefully the IC reasoning, IC problem solving resources literally just put those tasks at your fingertips. But this has been one of my absolute favorites for this. And the idea here is we can access this if we can find a way. So level 1 is if I find an answer. Level 2 is I can find different ways, and level 3 is I know how many ways there are. So let's say you think you find all the answers, and you think there's 4 answers. Let's say you're sure it's only 4. And what was your system? How do you know that there couldn't be a 5th one? And then we're looking for how the children have worked systematically to find what they think are all the possible answers. So again, let me go back to new share under the visualizer. So how many ways here? And let me get my my pen. And so again, we could maybe find a way of let's say, so we're trying to find, let's say our system is something like this. Let's find all the ways of making 1/4 first. Then I've got to think all the ways I could make a 1/4. Well, how could I do that? Well, it could be that I have how many 8s? I could have 1/8 and then 1/8 as being the same as a 1/4. So there's one that I could do. Are there any other ways I could make a 1/4? Well, it'd have to be an 1/8 add something. So that's the only way I can make a 1/4. And then so I could write that down. So it could be an 1/8 add an 1/8 equals a 1/4. And then I can say definitively, right, I found all the ways of making a 1/4. And then I could say, well, what about making 2/4? How can 2/4 be made? And again, I could be thinking, well, it could be I've got to add 1. Let's say I'm adding. Can I add 1/8? And yeah, I could add 1/8 and 3/8. So that would be something that I could do. And then I could look at, well, what about that? Well, let's say it's a 1/4, add 2/8. That could be another way. And then I can get to, there's 2 ways there. And then when I get to 3/4, I can look at, well, it could be I could have a 1/2. Or I could have a 1/4 here, I could have an 1/8 here. Or we could look at this one. Let's say we were looking at 2/4. Any ways of making 2/4. I could think, I mean, what could this be here? Could it be 12ths? Does it, and then we could get to, well, actually, if we were adding 1/12, I can't add an amount of 8s that will make 2/4. And again, kind of really exploring that. Now, this again, good for the back end of a sequence of lessons. So I wouldn't want to start with this because children obviously don't have the skills, but this is something that I would look at where children can kind of then go and explore in great depth. Now, what I wanted to come to was this idea that, and again, using the fractions cards for for then looking at the idea of fractions as counting numbers and leading into fractions on a number line, which is again a kind of another representation of fractions that children need if they're going to find fraction decimal equivalences. So what I'd often start off with is just showing on a number line, having a number line and showing, let's say, counting up in quarters. So we've got a quarter and 2 quarters. So let's say I have a quarter and then 2 quarters, and then we've got obviously 3 quarters, and then what have we got there? We've got 1, and then seeing another quarter, and so on and so forth. We've got 1 and a quarter, and keep going, and we can kind of see that representation. Now again, in terms of improper fractions, children seeing that's 5 quarters, and it's also 1 and a quarter is fabulous. You know, being able to see 2 as 8 quarters. I think the fractions cards are brilliant for that, and being able to manipulate in that way. Let's go back to new share and the screen. I also wanted to share this, just in case this would be helpful, because this is a representation that I'd like to use for getting children to see numbers, fractions on a number line, and fractions as counting numbers. So this is actually my eldest daughter from when she was a lot younger. And I have these images where she is getting a quarter of a year older as well, and for kind of showing this idea of fractions as counting numbers progressing over time. So again, hopefully that'll be helpful. Feel free to use that. Hopefully that'll be helpful, and if not, just admire the baby pictures. Now, in terms of finding fraction decimal equivalences, I wouldn't just use those, obviously the part whole representations. Whilst we're still obviously talking fractions, children have to see that I'd have to be able to position fractions on a number line as well and develop expertise in doing that. So what I'd often do there is have basically like a bar model, but like a thin strip, and children seeing how you would partition a 6 and 2 6 and 3 6 and thirds and quarters and so on, and getting the idea that a sixth will be not as far along, that essentially it's still division, and possibly being able to see and explain here also why 2/6 is the same as a third, and so on, and understanding why again a third is bigger than a quarter. And then I might again give children, for examples of positioning fractions on a number line, examples and non-examples. So for example, the children otherwise could think that a half is first because 2 and then 4 is bigger, and then maybe 3 quarters because they're the bigger numbers, and then 1. Or equally, where we have the fractions in the right order, but not spaced appropriately, and children being able to reason around that. Equally, it might be that this would be akin to the estimating the fraction where we have a part in a whole. We might have a position on a number line, and then asking children to estimate the fraction, and maybe have a slight variation in there. And again, this is for children to think, well, how many of this part goes in the whole? And again, I'm always doing it with my head when I'm on here for some reason. As I say, for kind of reasoning spatially as well. And then using those same representations essentially and looking at decimals. Now I'd often do this with big strips of like display backing tape. So like a meter of display backing tape, split into 10 intervals marked into decimals, 0.1, 0.2, 0.3, and children folding them. And then this isn't something that's easy to show here, but folding them and seeing like when they're folded in half, then we've got 2 pieces, and each piece is 0.5, and then folding it again and seeing that the fold comes in between 0.2 and 0.3, and children then needing to understand, and again, this representation is good for showing that tenths, you have like 3 tenths is 0.3, but it's because we count in a base 10 number system, and then understanding that, and that fractions are a different form of number than that. And us seeing this idea that our decimal system is split into tens, but our fifths in fives, and to make that relation between those two systems to find equivalent fractions. So again, they would generally be the representations that I would use. And once children are familiar with those representations, I would then look at how I can kind of remove those representations, maybe use them to show answers, but not have them so children can see them, and be thinking, how do I remove them successfully? So where am I? And again, just like looking the same idea, how do I build a sequence? I would then maybe go for misconceptions. So right answers, likely misconceptions. Which fractions have been positioned correctly? Can children explain, for example, that this isn't where a quarter goes? Or then true or false, odd one out is often one that I would use here as well. Something around this literally interpreting the numbers here, as you know, seeing the 3 and the 5, and you know, likely misconception here. And similarly, if I was looking at something like a 12th is 0.12, us understanding that it's only in tenths do we have this kind of direct comparison. And again, I've chosen these examples because these are relatively challenging, because actually a third and 0.3 and a 12th and 0.12 aren't far off the decimal equivalents, but they of course are incorrect, because 3 0.3s don't make 1. But again, like gradually building understanding in that way. Then very similarly, this is the same idea really. The how many ways task would then give us an extended exploration of this idea that I would do at the back end of a sequence of lessons. So make all the fractions that are more than 0.25 and less than 0.5 using these numbers. And for children to think, well, you know, it's got to be less than half, and so on and so forth. I'll not talk through that one. But again, it's the end point where children can say, oh yeah, I know that there are, I can't, off the top of my head, I can't remember, there are 3 answers. I know there can only be 3 answers because, and I would maybe get to the point of where children have found different answers, then interjecting and looking at the different systems that children have and how they know they think they found all the possible answers. Now, what I wanted to do is also show another technique which I love. Now, let's say I've often used this in comparing fractions as well, and really good for children writing their own questions, which again is ranked by difficulty. So if I could give you a moment on a couple of things, you feel free to answer which you found harder and easier and why, but specifically, which different strategies could children use to answer any of these questions? So again, if you could give your thoughts there. So the different strategies that children, that we might want children to recognize, rather than just always thinking what's the finding finding an equivalent fraction. And again, if you could load them in the chat, that'd be brilliant. Let me have a quick check of my notes what we've got to cover. Okay, I can't see anything coming through, but I'm sure they'll come through in a moment. Let me just kind of comment on some of the things that I'd look at and children might notice. It's this idea of perhaps giving them benchmark measures. And what I mean by that is thinking, well, more or less than half. So for example, 3/7 or 11/20, we might think that's very difficult to compare. But equally, if we're thinking, well, this is less than half and more than half, is one strategy they could use. Now, they could actually use that for 5/8 and 15/20 if they can think of that in terms of more or less in its comparison to 3/4. Or equally, we could say, well, this is really challenging because I've got to think, well, what's the common denominator that I could find? And then it might be that I compare fractions where there's the same denominator as opposed to fractions where there's the same numerator, or difference from, and again, number line is brilliant to show that, but difference from 1, how much less than 1. then when children design their own sequences, yeah, absolutely, paired with the visual representations for low retaining children, so they can see that idea. And great, when children design their own questions, it's really interesting. It gives you an insight into what they've understood when they come to you and which techniques they'll use. Because it might be that they'll design a rank by difficulty question and they'll write 4 questions which all use the strategy of more or less than half. And what we want to see is can they design questions where they are able to articulate, well, for this question you need to use this strategy, and for that one you need to use the other. And again, where would it come in? Like this later in a sequence of lessons. Now, what I wanted to do is just cover a couple of things in terms of representations that I would use for looking at fractions of amounts. Of course, it's a kind of a different concept as well. Move to just looking at a few ideas for depth in terms of improper fractions, and then a few other bits around how these ideas can apply in different curriculum areas, and some researchy bits for you to have a look at. Please, any questions that you've got, particularly in the Q&A, put them in if there's any. Well, what does this look like for me? We'll have some time at the end where we can go over any of that, so please go for that. So let's say a third of 12. What I might describe to children is you'd maybe start off by doing a third of 12 and getting sweets and splitting them into 3 equal groups, and we could have a look at that. So, you know, and that we've got to make sure it's the same in each group and so on. And then how we move from that to actually, when we have a larger quantity, we'll often use a bar model and write numbers there. So we don't need each of the individual items, but us understanding this relation between division and finding fractions of amounts. And then, of course, moving to looking at how the bar model is different than when we work out 3/4. And of course, the bar model, brilliant tool for this kind of question. So then again, similarly, it might be that some children need to access that with the counters at first, and then positioning them into spaces on the bar model. And we want them to go from the progression of seeing the counters to not needing the counters and just being able to complete the bar models with numbers. So maybe they do the calculation with the counters, and then we write the numbers in the sections of the bar model when they're removed. And we want them to get to the point where they don't need the counters anymore. And so we might work within a small number range for them to be able to do that. I might, again, give examples like these ones. Again, spot the mistake. I'm thinking the likely mistakes in bar models that children could make, and can they see it? So numbers not being the same, or mistake in the calculation, or in this case, marking on 4/5 rather than 3/5. Then again, like small variation questions. This is a great one for small variation questions, because I will naturally go for going from, let's say, for example, from a 1/5 to 4/5, I could go a 1/5 to 40 and a 1/5 of 80. The children actually just recognize, well, I can just double. So 4/5 of 80, I could get 4/5, or I could subtract a 1/5. And us recognizing that if I've got 4/5 of 80, you know, I can derive 2/5, or I could double or half the 80. And equally 4/5 of 85, then recognizing, well, that will actually be 4 more because I'm doing 4/5 of 5. And so having sequences where basically, rather than children just working out random fractions of random amounts, for them seeing those patterns in the fractions. So let's say you could double the number and double the denominator, and we'd have the same answer. But for children having questions that are deliberately presented in a sequence for that reason. Now, again, as we progress, I might go to I know and so. So this is a technique that I really like, particularly in this case. So children are able to like derive, I know, and therefore I can derive this other fact. And of course, this then gives children that greater scope, creativity. Once they've looked at the mechanics, they can say, well, I know this, and so I know 3/4 of 240. Now, a good one is if I know 3/4 of 24, you could do that with ones counters, and then showing 3/4 of 240, where we do that with tens counters to show those relations. And we can look at, again, how the bar models would be different. But again, it's just this whole thing of sequences. And then what I like doing, and this will cover a little bit in the problem solving courses, this is really the same thing of creating their numberless questions. So, and I say numberless questions, or removing numbers from questions to open up different possibilities. So we might say to children, okay, and that will generally more, rather than them thinking, well, what's the answer, is getting them focusing on, well, what's the relation between the quantities here? So let's say a quarter of equals, and for children having to see the link between the quantities, and, you know, and then I might say, can you come up with 3 possible answers? What could it be? And then having found what it could be, us clicking on the wrong thing there, Gareth, us going, well, actually a quarter of a number is 15. So what could the number be? And then, of course, I could do it where I don't present the numbers on the bar model. I just put the 15 there, or I could put the 15s in the bar model, and we can see 60. And so let's say here, 2/3 of a number is 14. What could the number be there? And essentially, I've got to look at that and think, well, what is the 14? So is the 14 the whole? Is it one of the orange boxes? Is it something else? And again, I can always, with these kind of questions, I can always think I can hide different bits and for children to see it different ways around. But if they've first explored it numberlessly and they found a possible answer, that's all often my kind of way into this kind of thing, for them to see the relations. So actually we'd see here, so 2/3 of a number is 14. So each third must be 7. And so that number 21. And again, this might lead into questions like these ones. So this is a lower key stage 2 example. So fill the gaps. And we want children to recognize that what we're looking for is that 6 times 4 equals 24. So I need to multiply the denominator by our answer here, and that will give the whole that we're breaking down. Now, one of my favorite and most challenging then tasks for children to unpick is this one. Actually, I'll just write this down on here. And again, lots of depth here in the kind of looking at the bar model. So this one is from IC problem solving. And let's go under the visualizer, new share, the visualizer there, and children having a look at, say, 2 somethings of something equals 32. And it's kind of us recognizing that, and often like drawing it and almost like covering up the end of the bar model. I can't actually see what I'm drawing there, so let me just move this on my screen. But then recognizing that what we have is we have these, you know, these 2 parts, and those 2 parts are 32. You know, and if sorry, it's my favorite book there, I'll use it to cover the option to come up with something that was blank. So that so they've got to be 16. And so then it could be, let's say it could be 2/3. If it's thirds, I'd need another 16 here. It could be quarters. If it's quarters, I need 2 more 16s. If it's fifths, and so on. But great chance, end of a sequence of lessons, to kind of explore those ideas in depth. Okay, again, any questions? If that doesn't make sense, please ask me, put it on the chat, and we'll have a look at that. Before we finish, I want to just throw in a few little ideas. So this is really good. I would just say that this is, again, I'll just put these examples up because I want to make sure we cover everything and you have time to ask any questions and so on. But answer this question in 2 different ways. So 3 1/4 equals, and looking at improper fractions. Again, fractions cards, just perfect for this, because you could make this with quarters, and you could see that 1 is 4 quarters, 2 is 8 quarters, 3 is 12 quarters, and another quarter. But then again, we could look at, well, how else could that be made? And for example, if we have a look at that in 8s, again, it's looking at what's 1, and we're looking at fractions that go into equivalent fractions to a quarter, to find different possibilities. And again, this is the one of the IC problem solving tasks, and again, really like this. And I wanted to give lots of examples of things that you could use at the end of a sequence of lessons, again, if you wanted to kind of deepen the challenge. So if I'm thinking 17 over what equals 2, and for children thinking, so what could this fraction, what could the denominator be here? And that would leave 2 and how many? So you've got to think, like, for example, it couldn't be quarters, because if I had 8 quarters, that would be 2. 12 quarters would be 3. So I've got to think, well, how do I change from there? Could it be fifths and sixths and so on? And how do I know when I've found all the possible answers? So again, like, enormous potential for depth there. Now, let me give you a moment. I'm going to come to this in a second. But let me just show you 1 or 2 bits on the website first of all. And again, let me give you, this would be a great moment if anyone has questions to load them in. Just to recap for those that didn't see this initially. So this page will have the recording from now on it. So if you've missed anything, you want to look back at it, then it'll be on there. This page is www.icmaths.com/CPD Reasoning 1. The presentation is there. There's some other bits here. So the fractions cards, there's a link to them. There's a link to them on the web page, on the website, on free resources, games and resources. There's also this link here, so they can just be printed. Hopefully they're going to be really helpful. We'll come to that in a moment. I'm about to refer to something, to this book, Rosenshine's Principles in Action, and some of the points from it. They are also neatly summarized from someone who came on this course when it was previously done. And she pointed out that this article is great for explaining a lot of those points as well. So if you want to do a bit of reading stemming from this, then that explains a lot of the principles that we've looked at here, research-based strategies for teachers. So again, that's a really good thing to have a look at. Now, what I also wanted to refer to was this, progression in questioning, Key Stage 2 reasoning. So if you click on this document here, it brings up this. Now, we've looked at fractions here. So a lot of the examples that we've looked at are here. And there's also a top example, which is progression in reasoning in multiplication. So what I thought would be, there's a couple of comments I've just seen. I've not got as far as reading them. I will do that in a moment. That the idea is that, like, you could, there's a second version of this, of the reasoning Key Stage 2 maths, which is around multiplication and division. So we'll actually cover this content then. And again, you're very welcome to join me for that. But even if you haven't, then this is free, you can use this. So progression in reasoning for fractions. And the idea here is this, from the feedback from the first time the course was run, people were kind of saying, it'd be useful to have something to demonstrate this when we try and roll this out in our school. And so this is my attempt to do that. And it was looking at this idea of building sequences of lessons and how the kinds of experiences children will have differ from when they're novice to when they're building expertise. So it's this idea, at first we might look more at the visuals, less challenging the calculation that's used, activating prior intuitive knowledge. We might move to those broken down questions, explain the mistakes. And then we get to the more open-ended, different possibilities, ranked by difficulty, and then moving more towards where children create their own questions where they can find multiple possible answers. And there generally being a slight shift from more to less, more direct teaching to slightly more open-ended challenge throughout that sequence. But understanding the children's level of expertise, where in the sequence of lessons we are, and that's why I'm structuring the lesson in this way, is some of that kind of key dialogue. Yeah, this is a great question. Would you have a set of fraction cards just for yourself as the teacher, or one per child? Now, that in truth depends on the context, and it depends a little bit on the class, because I've done both. I've done it with my class where it's worked well. I've actually done it because now I work in a number of different schools, and there was like one class that every child has the fractions cards, it'll be chaos. So I might do it where I model it, and then I work with a group of children with the fractions cards, because actually for them, they'll end up thinking about other things, because the way they actually manage the resources, and so I would think, is that going to focus children's attention on this key idea, or is there going to be a difficulty with the fractions cards just logistically? It's a lot to make if you do them for everyone as well. That's the only other thing. Although they're quite easy to make, and once you've got a set, you can keep them. But great question, and that's a really important question as well, logistically. Now, what I'm going to do is I'm going to go to New Share, and I just very quickly wanted to point to. I'm going to actually come back to this in a moment. I just wanted to point to, basically, just for a few minutes, how the things that we've looked at, the principles of building a sequence of lessons, really the same in pretty well any curriculum area. And I just wanted to point to literally one or two ideas and things for that. And you literally have these resources. Let's say when I'm teaching children to written methods for division, there's so much that children have to do all at once. And what I've traditionally done is shown them how to do it. You go and do it. And what do? Some of them can do it, and they have to think, well, what did Mr. Metcalf do? Oh, yeah, and I've managed to do that. Hey, you know, whoopie-doo-dah, because I've got all these skills, and I know them all already, and the times tables, no problem. That didn't take any of my working memory. I can do it. Other children are lost because they've got too much to remember all at once. They're maybe not fluent on the times table recall. They're trying to understand what's happening. Too much all at once. Cognitive overload. What I would suggest is, if that's the case for those children, just focus their thinking on one thing. For me, it would be, what's the remainder? Say, let's say this example here. How many 3s in 8? There's 2. What's the remainder? Well, I've got to think, well, 3 times 2 is 6. And it obviously gets harder as well when I'm doing the second part. When 3 times 2 is 6. And then I've got to do that. And then I've got to think, so this is 8. What's the difference between 8 and 6? That's the remainder. Now, if I'm doing that and I'm also thinking about the layout and I've got to do everything else, I might kind of get lost in that process. So what I might do for some children is just, particularly early on, is just focus the thinking on one step. Similarly, part complete examples is what I'm getting at. Let's say we're multiplying 3-digit numbers. I might do all of the calculation apart from this one step or a couple of steps. So children have already got a useful model. And then they've got to think, right, so 5 times 4 is 20, and then I've got to add that 4. And just focus on that, not have to do everything. Similarly here, 4 times 3 is 12. Put the 2 down. That's 110 there. And then I've got to do 4 2s are 8, add the 1 is 9. I'm trying to make the calculation so it's relatively accessible at this point here. But that as a principle, I think, is really powerful. Similarly, always have explain the mistakes examples. So like, children are reading, this is from IC Reasoning. It came from children making these mistakes in my class. So now beforehand, before they get the protractor, they've got to look at these and be able to say, read the wrong side of the protractor. They went for 3 degrees more than 20, where it's less than 20, not lined up the protractor properly. And, you know, loads of, this is one of my favorites, so I just put it so you can have it. How many ways can this be done? So if I'm looking at moving children to greater depth, but I don't want to increase the number range, love this task. So complete using the digits 0 to 9. So they've only got one of each digit. The digit in the box with a border must be odd. So here, children have got a figure. So if this digit must be odd, then actually this is quite limited, because I've got to make an odd number. I've got to multiply to make an odd number. I've only got the digits 0 to 9. Then it's got to be an odd number times an odd number to make an odd number. So looking at my odd numbers, I've got 1, 3, 5, 7, 9. And it can't be the 5. Can't use the 5 there or there, because that's going to give me a 5 or a 0. And I've only got 1 5. And so then I've got to think, well, and there's very few answers. But again, children going from, I can find an answer to, I can find different answers to, I know how many answers there are. Fabulous level of challenge. Anyway, let me finish. I'm surprisingly well timed. I'm normally either, I normally have more to cram in, and I'm then talking at 100 miles an hour, which I might be doing anyway. But what I wanted to do was finish with this. And it's again, some research that I've read, and it is neatly summarized by this book. This is always the thing that suggests Rosenshine's Principles in Action, because it's thin and it's succinct and it's good quality stuff. But it talks about a lot of the principles that we've looked at today. If you wanted to take something further, then I would say to do that. And it talks about this idea of where in a sequence of lessons, and also the idea that one lesson isn't a good unit of time to judge learning, because learning is about changing long-term memory. And that happens over time. And I have to think about this constant interplay between working memory from what we've done today, and then we go to sleep. And then those experiences, what happens is we change our long-term memory. And so then we come back the next day and we've got to bring that back in, and so on and so forth. And again, it's about thinking, so how am I changing children's long-term memory over the course of time, rather than thinking, was today's lesson successful? Because the lesson might have looked good, but what I might not have done necessarily is that might not necessarily translate into changing long-term memory. And understanding what works well is important for that. And what this book talks about is the importance, as well as many other things, of prior learning. We are literally building on prior learning, because our working memory has got to go and attach to something that we already understand. That is how it attaches in our long-term memory. So in the beginning of a lesson, having time to recap. More successful teachers generally spend longer activating prior learning, generally speaking. I also used to put the hardest thing in my lessons last. I've since learned, bad idea, because what I should be doing is showing, like, this is what you did know. Now you know this is how I've built on what you knew previously. So your learning might not look as impressive, but it will be more effective in attaching to long-term memory. And so I'll be able to retain more. I wanted to look at two other main things. One was the idea that this book describes how teaching is generally something like this. I show you how to do it. You go and do it. We do it together, and then you work independently. And it said that more successful teachers generally have longer in the we phase. We do it together, and we unpick the difficulties, and you see the thinking of that process. And then when you go and work independently, it might be slightly shorter generally, but you have a higher success rate than less effective teachers, who are more characterized by, I show you how to do it. We have longer in the you go and do it, and less success at the time where children are working independently. So again, some food for thought there. Maybe the difficulty coming in the middle, where we're working on it together, but children having a relatively higher success rate in the you phase. The other thing was around long-term memory and ways that we can reinforce long-term memory. It's very common for people to say, oh, they could do that in the lesson, and then they could do that 3 weeks ago, or when they were in my class, and where's it gone? Space practice, then the kind of key ideas that we've got to get when we're looking at that. I forgot the terminology now. Storage strength and retrieval strength. There we go. So storage strength is, did it link well to my previous learning? Does it link to what I understand about the world? Did I show it visually? Is it well attached to other stimuli, if you like? Learning has higher storage strength than if I just say, this is this written method, this is how you convert the fractions. Then I might be able to do it for that lesson, but it won't attach as well to my long-term memory. But the other aspect is retrieval strength, is how well can I find that memory again? And what I need to do, the thing with the best evidence for working is spaced practice, where basically children learn something, then there's a time lag. So maybe they have 2 weeks where they don't learn it again, and then they have to bring that thing which I once learned and it went into my long-term memory, and I've got to keep revisiting it, bringing it back into my working memory and sending it back again. So if I don't do that, I'll forget it. And we forget a remarkable amount of what we've learned if we don't revisit it. You're telling your brain, don't forget that thing, and you're showing it how to store it again when it goes back to its long-term memory. So often schools might have, we did this, something I did last week, something I did last Something I did yesterday, something I did last week, something I did last month, last term.